So let me just start from where I left off. I think I just gave a brief introduction on thermodynamics. So the best way to explain that is the PV graphs which you have noted down. The PV graphs. And also we just discussed about some gas laws such as the Boyle's law, the Charles law, and there was the pressure law. These are the things. So I just explain all of them in terms of these graphs. This Boyle's law is considered as isothermal lines. Isothermal lines, which will look like something in this way. And you should understand that temperature is a constant in this process. The temperature is a constant. So there is no any internal energy change. So delta U is equal to 0. And I will explain what are they. And also, the Charles law is a case where volume is varying with temperature. So the volume is going to change, but the pressure is a constant. So you should understand this horizontal straight line. And find the pressure law, where the pressure changes with the temperature. And I say that is really important even to learn the velocity of sound in air. So that's the case where there's a vertical line. So these were the cases which we described. So hope you remember them. So let's start from where we left off. So I said to you that this is somewhat important, and I'll explain the reason why it is. So if you take the tutorial 2, we have been given a question that I think the question number 6, where they are saying us a gas is confined into a closed container. Consider the following statements made regarding the speed of sound in the gas. So the speed of sound does not change when the volume of the container is changed at constant temperature. So even I was just saying, I'll describe it a bit later. So I say that the velocity of sound is gamma RT over molar mass, and I'll explain that also in a while. Gamma represents specific heat capacity at constant pressure or specific heat capacity at constant volume. So you can see there is no volume in this section, but you should understand the basic equation PV equal nRT, which you have already learned in our ideal gas law. So from here, if I just slightly rearrange this, moles is mass divided by molar mass into RT. So you can see that pressure is equal to M over V RT over molar mass. So we can find that the pressure over density is equal to RT over molar mass. So we can substitute onto here. So the velocity of sound in air is equal to, instead of RT over molar mass, gamma P over density. We can also get into an equation like this. So you can see, they are asking us the question, the speed of sound does not change when the volume of the container is changed at constant temperature. So understand. So this is my equation. The pressure, you might think, okay, pressure over density is equal to RT over molar mass. So you should understand when the temperature is a constant, and anyways the molar mass of a substance is a constant. When R is a constant, this P over density would remain as a constant. P over density would remain as a constant. which means if you increase the pressure, the density is also going to increase to maintain this as a constant. So in our statement A, this pressure over density part will remain a constant at constant temperature. At constant temperature. Okay. So you should understand, in these scenarios, even if you start varying the volume, this doesn't affect our equation. Okay, you can see if you change the volume, the density will change. So in result, the pressure is going to change. So my statement is correct. You can write the reason behind it. When the volume changes at constant temperature, its density varies. And the pressure is also going to vary. Proportional to it. Okay. So the velocity of sound in air will remain the same. Okay, so this is an important point. So it's not actually from the pressure though, okay? It's not pressure with temperature, it's actually the Boyle's law, right? Pressure and the volume at constant temperature. And if you look at the statement B, the speed of sound changes with temperature. Of course, you can see it's directly proportional to square root of temperature. So that's a correct statement. In the statement C, the speed of sound changes when more gas is added to the container at constant temperature. So you should understand that's a false statement, because why? The molar mass will remain the same if you are adding the same type of gas, and they are saying the temperature is a constant. So it is A and B for question number 6. For question number 6 is A and B. Okay. And if you are in confusion, just let me know, okay? So just discuss that because it's somewhat related to the gas laws and our thermodynamics part. Okay, so shall I erase them? Just take a screenshot of this, okay? These are the things slightly you should know, okay? And now let's start to work on problems. Now we know that the Boyle's law is temperature is maintained a constant. And the most common thing for all of them is, even for the combined gas law, we have PV1 over T1 is equal to P2V2 over T2. For all of them, the mass will remain the constant. The mass of the gas will remain a constant. So you should understand, if they are saying a statement like, for a fixed sample of an ideal gas, it means the mass of the gas is a constant. So when you are dealing these questions, just focus on this stuff, because they will indirectly say them. Okay. So let's start today's session then. I think we have to discuss on adiabatic process, and I will just deal on questions of Boyle's law, okay? Because I have just given a note behind this stuff, but without trying question, there is no meaning for them. So let's deal with adiabatic process, then I will return to here. Now what does adiabatic process say is a quick process. Just get the understanding. Isothermal is also known as a slow process, where there is no any change in temperature. But this adiabatic process, process are called as quick process, which take place quickly. So because of this, the gases do not get enough time to exchange their heat with the external surrounding. So in this adiabatic process, the delta Q will be equal to 0. The change in heat will be equal to 0. So can anyone say me an example behind it? So there's a process of, if you start pump air into a tire, if you rapidly pump air, this tire will start to expand. So that's also fine, but we haven't practiced. That means there's no any exact information. Just by reading things, we are just getting that that idea. So if you really want to practice that adiabatic process, what you can do here is just take your hand, blow some air. Now the first case, have your mouth widely open, completely open, and start blowing some air. You can feel somewhat a warm air on your hands. You will feel a warm air in your hand. Okay? And now, like whistling, again have your hand. Now with a smaller opening, start blow out the air. And when you start getting this air in contact with your hand, you will feel somewhat a coolness. If you want, just try that, okay? When it is widely open, you will feel a warmness. When it is slightly open, like whistling, you will feel a coolness. That is mainly big. Okay, you can also say it mainly because of adiabatic process. I'll say why it is. Because even in hydrostatic, you have learned when the area is larger, the outlet velocity is lower. So in here, the velocity is greater. The air is releasing out very quickly. But whereas in here, the outlet is wider, so the air is releasing slowly. So you should understand, in this situation, there is an adiabatic process. Not only adiabatic, there are some other cases, but you can relate your stuff. Okay? So there is no any heat exchange in an adiabatic process. So that's a key idea you should understand. Okay? So next time if they get an MCQ, to maintain an adiabatic process, the outlet has to be wider or smaller. They can ask those stuff. So just get an understanding. If the outlet speed is greater, it's a quick process. So we can maintain an adiabatic to some extreme. Okay? So that's the basic understanding behind adiabatic process. And like I have denoted these stuff in my PV graph. If I start to denote an adiabatic process, now you can see this is my isothermal line, the PV. This is my isothermal line. The adiabatic process will be somewhat steeper than an isothermal line. It's somewhat inward to that. Okay? So just note these things down. So the general equation behind an adiabatic process is PV to the power n is a constant. You just get that understanding. PV to the power n is a constant in an adiabatic process. So these are the most important things you should know. The heat exchange is 0. The governing equation is PV to the power n is a constant, and it is somewhat steeper than, you can see it's somewhat inward than isothermal line. Isothermal. And you can see an adiabatic process. these are the most essential things behind adiabatic, and mostly you'll be getting a small amount of questions behind it. They might ask the heat exchange and which is that adiabatic pathway. They can ask those stuff, okay? So just remember them. And this governing equation, I'll say a reason, okay? Still they haven't given any question with this, but I'll just get your question, okay? Now itself. So just note these things down. The heat exchange is 0. It is somewhat steeper than an isothermal line, invert, and the Tv to the power n is a constant. Okay. Now still I haven't given an idea about this sign convention. I'll come to it. But let's get the basics behind them. Okay. These are the basic stuff behind them, and I'll just teach the sign convention in a while. And if I just raise the question, now they can get an MCQ behind them. Is the work done in an isothermal line at a given temperature greater or less than an adiabatic process? Now let's say they have given a graph like this. This is my isothermal line. This is my adiabatic pathway. If I ask you a question, who has the higher work done? What can you answer? Because we haven't dealt any equation to find the work done of curves, usually straight lines, like triangles. Those ones we used to find the area. But without mathematics, like integration, you can't find the area under here. Now, who has the higher work done? Is it an isothermal line or an adiabatic process at here? Yeah, of course it will be an adiabatic process, because now if you look at here, it will be important for your cyclic process as well. If you look at here, now my isothermal line, this is the area. This section is my area. This entire section is my area. But if you take an adiabatic process, this is my area. Okay, I just mark in stars. So you should understand there is only a smaller area covered by an adiabatic process than an isothermal process. So you can just note that also down. Adiabatic process covers a smaller area than an isothermal pathway. So the work done in an isothermal path is greater than work done in an adiabatic path. Some small information which you haven't noted down, so I'm just giving them, okay? Like in case if they give an MCQ, you can write them. So just note these small things down, okay? Because even in thermodynamics, every time they question about the PV graphs, the work done and those stuff. So in case, like after 40th MCQ, they note these things down, it will be important, okay? So fine with that. So those are the essential things behind your adiabatic process. And after that, let's deal some questions. But before that, is everything fine? Okay, so it's not hurrying up things. The basics behind adiabatic, there's nothing which we study in detail. The later things we have to deal with questions, okay? I'll just deal them down. For now, let's finish it here. And just remember it, as I said, now I'll just get your question for it. Now I'm saying you, okay, PV to the power n is a constant. Now I'll be giving a question indirect, like let's say, for a fixed sample of an ideal gas, there's an adiabatic process undergone. What is the following answers correct? That was actually from one of my FWC papers. So you can see PV to the power n is a constant. So if they want to question something additional, they might question with the density, let's say. Now I said right, it's a fixed sample of an ideal gas. The mass is not changing. So if I divide the entire thing by m to the power n, the mass is a constant. So constant divided by another constant will also give you another constant. So you should understand PV over m whole thing to the power n is a constant. So pressure, mass over volume is your density. So volume over mass is inverse of your density to the power n is a constant. So you can write pressure over density to the power n is a constant. Okay, there's some small things to note them down. So nothing much in detail for this adiabatic process. Only thing you should remember is heat exchange is 0, something steeper than the isothermal line. This is my governing equation. So now let's move to the main part of our thermodynamics. Still we haven't started that down. I just gave a brief introduction on these laws and some process. Still we have cyclic process left. But before that, I'll start dealing with the sign convention. So I said you the zeroth law of thermodynamics. The zeroth law of thermodynamics. You should understand there are actually zeroth law and first law. That's it for your syllabus. Zeroth law states that a thermal equilibrium is between the system, and the first law states that, like a conservation of energy, there's no heat destroyed or created. It's just transferred from one phase to another phase. So the first law, it says that delta Q, heat exchange, is equal to work done plus change in internal energy. So if you want to deal these sort of questions, you should know the sign convention before. Now the sign convention is, this is something like your enthalpy, which you learn in chemistry. If it is absorbing heat, it is an endothermic process. So there is a positive energy, positive sign, okay? If it is absorbing heat. If it is releasing heat, it is an exothermic process. So there is a negative sign for this. So that's why I have just given in the table. Heat output is positive, heat input is negative. Okay, I have made a mistake, okay. Heat input is positive, okay. The table I have made a mistake. Heat input and heat output. So just remember them. And similarly, if you take the work done, if a gas is expanding, it is work output and it is positive. So work output is positive. Output is positive. Work input is negative. It is negative. So these are the basic sign convention to be used in your thermodynamics equation. So just remember them. And I just get you some ideas how to solve these questions. Now let's say if I just draw a PV graph, let's say there's a point A, it has a constant volume process, a constant pressure process, the charge flow, and then it is increasing, let's say, the pressure low, and it is reaching this point B. So from A, C, B. So you should understand, let's say if they ask the heat change or something between A and B, you can write this equation from A to C. You can see from A to C, the volume is expanding and the temperature is also changing. So you are having an internal energy change and a work done. So you should have a delta Q. If I write with the sign convention, delta Q is equal to work done is positive. Change in internal energy. If the temperature is increasing, it's again positive. Which means in the process A to C, you are getting a positive answer. So there is a heat input to the system. And from C to B, there is a constant volume process. The volume is neither expanding or reducing. So you should understand, in this process, the work done is 0. So delta Q is equal to work done is 0 plus, if the temperature is increasing, it's positive, okay? And just note these things down, because sometimes they might get a isothermal line. If so, the temperature is a constant, but not in here, okay? So this is the way how we just did the question. So if we ask from A to B, you can get these two answers. A to B is, there's a positive work done throughout. There's a positive internal energy throughout. So the delta Q will be the addition of these two answers. Okay. So now in result, if I ask you this way, in the path from A to B, what can you say about the internal energy change? Because the temperature from A to B, even if you go this way or even if you go this way, the temperature is not changing, right? If the temperature is T1, T2, from here of course you are going for a different temperature, but finally you are ending this same final path. So the temperature change is T2 minus T1, even if I follow this pathway, and even if I follow this pathway, I am having the same internal energy change. Because why? The temperatures at A and B are fixed. They never change. It's nothing like you are just willing to go for your home. There are two different shortcuts. So whether you move from A, C, B or just directly from A to B, temperature change is the same. So the internal energy change in here and the internal energy change in here are the same. Okay? Both of these parts are the same. So you can just note that down as well. Starting and ending point, even different pathway, you will have the same internal energy change. Okay? So I'll just explain more in detail when it comes to a question. Because without a question, there's actually no meaning. Now they might ask you, what is the work done in A to B? Now you can't say that we can't find the area under curves. Because with this information, you should be able to calculate this. Okay, I think I might have given a question. Wait, let me just look at that. Yeah, question number 5. So let's try question number 5 then. So I'm just erasing this graph which I did previously. Question number 5. Question number 5. And let me just mark the arrow heads. But before that, let me just read. The graph below depicts the variation of pressure versus volume for a given amount of an ideal gas while undergoing a specific process. In process AB and BC, heat energy of 600 and 200 was provided. It means there is a heat input, okay, not an output. So from the process AB and BC, A to B there was a 600 joule heat supplied, so it is positive. In the process BC there was a 200 joule heat, which is also positive. If you look at the other one, what is the internal energy change in process AC? They are asking the internal energy change in AC. So you should understand the same idea. Even if I move from A, B, C or directly from A to C, the ending point is the same. There are different pathways. So the internal energy change from A to C is also the internal energy change from A, B, C as well. That's the idea you have to figure out first. So now let's find it. Now you can find it. Internal energy change from A to C has to be found. But before that, let's try to work on this. If I write an equation for A to B, delta Q is equal to delta U plus delta W. Now the heat change is 600. There is a heat input that is positive. 600. There is an internal energy change because there is a temperature change, but we don't know it. Let's mark it U1. And what about the work done? That will be 0 because you can see it's a constant volume process. The volume is not expanding or reducing. So, internal energy change from A to B is 600. Now if I ask to find for B to C, delta Q is equal to delta U plus delta W. Heat exchange is 200 joules. And you can find the internal energy change is unknown, delta U1 plus the work done. Now observe, you can't see the work done is 0 because the volume is changing from this point to this point. Okay, so we have to know that volume change. So we have to find the area under the graph, this entire area. Okay, if I just go it separately. The volume is from 2 to 5. Pressure is maintained constant, that is 8. So you should understand the work done is the area under the graph. So this part is 3, height is 8. So work done is 3 times 8 is 24 joules. And what about the sign? The gas is expanding, so it's a positive sign. So now let's start to work on the problem. Here we are having 24 joules. Sorry, they have given 10 to the power 80. 8 into 10 to the power 4 Pascal. This is 3 into 10 to the power minus 3. So be careful with the unit as well. So it has to be 240 joules. 8 times is 24. It has to be 240 joules, okay? So you can find that internal energy change is minus 40 joules. Minus 40 joules. So the overall internal energy change from A, B to C will be the addition of these two answers. So you can see the total energy change from A to C will be around 600 minus 40, which is 560 joules, which is your answer number 2, okay? So just see how to deal with the sign convention. If the gas is expanding, work output that is positive, and see there's a straight line, which means it's a constant volume process, work done is 0, okay? So this is actually easy because if you know the stuff, you can just work on them. Now sometimes they might not say there's an isothermal line, because in an isothermal line the work done is 0, we know that. But instead of giving it directly, let's say in the same graph, I'll just draw the same graph. Instead of giving it directly, they will be giving a curve like this, okay? You should understand, if the PV product, the pressure is 8 and let's say the volume is 2, in here the pressure is 6, let's say the volume is 4, okay? If you multiply 8 into 3 is 24 joules, 6 into 4 is 24 joules, okay? So you should understand the PV product is the same. You are getting the same answer 24. 8 into 3, 6 into 4. PV product at A and B are the same. Okay? Which means it is an isothermal line. So they can just trick you with those stuff. Okay? And I'll just get you a question behind that. In this PDF, there's no questions. Okay? So this is the basic way of dealing this. And if it is fine, let's move to question number 11 then. So just try the question number 11, where they are saying answer graph of pressure and absolute temperature. Now it's not volume, okay, be careful. Absolute temperature of an ideal gas of a given mass as shown below during the process from P to Q. Consider the following statements in terms of the graphs, okay? So I'll just write them, I'll just erase this stuff. The answer is 560 joules. Let me just erase them. So they can, as I said, they can trick you with those things. They won't get you adiabatic process. If there's an adiabatic, they will be giving that. But to observe an isothermal process, you should understand, just take the PV product at 2 points to verify it, okay? So let's look at question number 11. In that, they have given the respective pressure 2P Okay, so let's try them. They're saying us A, the curve A. At curve A, the density of the gas decreases. And how you can actually get a blind information behind it? Because the pressure and the temperature is given. How can you actually think about the density? Now the reason why I joined thermodynamics and gas laws together is to get these ideas. Okay, there's no any order in following heat. So the main plan is after finishing this, we can deal with the conduction. So it is somewhat easy. Then let's move to the Newton's law of cooling. After that, there's no any connecting point. But gas laws and thermodynamics, somewhat you can relate them. Okay. And next time I'll just get your structure as well for the waves. Where you have to just think about this thermodynamics also. That means velocity of sound, gamma RT over molar mass. That velocity is used in tubes. Okay. So I'll just get your structure behind it. For now, let's deal this question for now. Okay. Now there can be also confusion in just drawing graphs as well. Now for that I have given a question in tutorial 2. So just drawing graphs, you might get confusions among you. For drawing graphs you might get some confusion. So just see what is your y-axis, it's your pressure. What is your x-axis, it's your temperature. And you know the basic ideal gas law is PV equal nRT. So y-axis has to be made the subject. So P is equal to N over V RT. And we also derived another one part. Pressure is equal to density over molar mass. Density over molar mass times R into T. Now you can see that pressure is your y-axis, temperature is your x-axis. Now R is a constant, molar mass is a constant, but you can't think about the density. It's fine with that. Now see, in this question, it's like it is passing through the origin, right? They haven't given us exactly, but it is like it is passing through the origin. Okay, if it's a proper past paper question, they'll be giving that. How I also determine that is, okay, you can see something like it is passing through the origin. So you should understand this entire thing will be a constant. Then only you will be getting a format like y equal mx. If the gradient is changing, the density is changing, entire gradient is going to change. Because molar mass and R is a constant. If the density is changing, entire gradient is going to change. Okay, so the gradient is fixed, and more importantly, it is passing through the origin. So get an idea. Okay, even if it isn't passing through the origin, you can say the density is a constant. Because why? Now in here the temperature is in Kelvin. If I consider in Celsius, I should get a 273. Right? Then you will get the format y equal mx plus c. So I'll just get you questions, draw them as well, get an idea. If the temperature is in Kelvin, you are having y equal mx format. If the temperature is in T plus 273 or else in Celsius, to make it Kelvin, you have to use 273. You have to add them. It is like adding x plus c, another constant. Then you won't get from the origin, you will be getting somewhere from here. You will be having an intercept. So whatever case, if the gradient in a T is a constant, you should understand gradient is a constant means PR over molar mass is a constant, and anyways R and molar mass is a constant. So my density will be a constant. So my statement A, at curve A, the density of the gas decreases. It's a wrong statement. It is a constant. Okay. So just when it comes to graph, you might think so much. The best thing you can do is get the equation behind the graph. So you can see the pressure and temperature. So just think, in thermodynamics, how can I just get pressure and temperature? You might not get it. But in gas laws, we have PV equal nRT. So we can connect those stuff. Okay. So statement A is wrong. Let's see statement B. I don't think it's a constant pressure process. Constant volume process. I think it's a constant volume process. The pressure is changing. The temperature is also changing. Sorry, the pressure is not changing. Okay, it's 2P. It's fixed. So if I just go to my equation, PV equal nRT. And what they have question? The density of the gas decreases. Let's look at that, okay? You can see if I write the equation. This is my equation, okay? Pressure is equal to density over molar mass R into T. Now if you look at here, the pressure is a constant. So I'm going to take this to the other side. So temperature is equal to pressure into molar mass. Pressure into molar mass over R into my density. Okay. Now understand, pressure is a constant in this part. Because why? It is fixed at 2P. So pressure is a constant. Molar mass is anyways a constant. Universal gas constant, no need to say, it's a constant. So this entire thing is a constant. Now if you are saying that density is a constant now, if density is a constant, temperature should also be a constant then. That means T has to be a fixed answer. You can't have a different answer. But you should understand the temperature is changing from 200 to 400 Kelvin, which means when the temperature is increasing, you can see temperature is inversely proportional to the density. Temperature is inversely proportional to the density. So when the temperature increases, density should reduce. So see how I just deal with this equation. The basic equation behind my graph is pressure equal density R over molar mass, my temperature. So in here the pressure is maintained a constant. So I made all as a constant now. And they ask me about the density specifically, okay? That's why I made the density here. So you can see the temperature is inversely proportional to the density. So when temperature increases, density should reduce. And you might have noted that down. It is a constant pressure process, which means it is obeying the charge law here. In this case, it is obeying the charge law. So these are some things which you can do in your past papers. When you deal the questions, after everything is finished, you can go for further information. Because we have been learned with PV graphs. So suddenly when they give PT graph, just note these things down. Okay, this is a charge law. This is a pressure law. Okay. So the statement B, the density of the gas decreases, is a correct statement. And statement C, at curve C, the density of the gas decreases. Okay, let's look at that. It is a constant temperature process. Okay, you can see it's a straight line. Constant temperature. So the same equation, the temperature is a constant. So this is which I tried previously. That velocity of a sound doesn't change if I start changing the volume. That equation. At constant temperature, that same thing. So you can see pressure equal density R over molar mass is into temperature. So temperature is a constant. So I took density to the other side. So pressure over density will be equal to RT over molar mass. Now the temperature is a constant. Molar mass is anyways a constant. So you should figure out that pressure over density will be a constant. So what should actually happen? If the pressure is increasing, density should increase. But in this question, the pressure is reducing from 2P to P. So the density has to reduce in this case. So at curve C, the density of the gas decreases. It's a correct statement. So answer is B and C for question number 11. Okay. And yeah, only that much thermodynamics question in tute 1. There's another one as well, so you can write from your side. I'm asking the work done, okay? If you just nicely look at it, you will find an answer. And I'll also complete cyclic process, so you can write a bit detail. So just see how to deal this thermodynamics part. If I just get you this one, it's somewhat easy. And let's do more questions based on them. Because as I said, they can hide an isothermal line in between. They might not draw it, but they can hide it. I think I faced a similar question. So I'll just share with you. And another one part is, if they are giving you graphs, get an idea from the gas laws only they are deriving equation. And mostly the basic ideal gas law. So now let's move to the cyclic process. So let me just erase these ones. So let's move to the cyclic process in here, because question number 9 is also cyclic process. The reason why I say to learn sign convention before is there is a table to be filled right here. I have just filled that information, but let's look at what I am saying. So there are two types of cyclic process. One is clockwise and the other one is anti-clockwise. Now let's say I am starting from point A. There's B here. So I'm starting from A, I'm moving this way, like a clock, okay? And then from B to A. So now see the point. I'm starting at A, I'm moving to B, and I'm returning back to A, which means if the temperature was T1, I had to face a different temperature T2. But I am back to my home itself. I am coming back to the same place. So, the temperature change throughout is T1 minus T1, which is 0. So, you can see there is no any temperature change. So, you should understand the internal energy change should be 0. Not the internal energy change has to be 0. So that's why I have given return back to its initial state. So the internal energy is equal to 0. And that's also another process, the cyclic, anti-clockwise. I'm from A to B, I'm moving the downward way. Then I'm returning here. So these are the basically two types of cyclic process. And you should understand the reason why I am saying this part. See here. You know that delta Q is equal to delta U plus delta W. Delta Q is equal to delta U plus delta W. I said you that throughout this process, the internal energy change is 0. So delta Q is equal to delta W. So whatever heat exchanged in here is directly transferred to my work done. It's neither used to increase the temperature nor reduce the temperature. Okay, that's the point you should note down here. And I'll say you the reason why I have just added the other parts as well. So you can see in here, I'm just erasing this part for a while. You can see there's a work output, right? The gas has expanded. From this point to this point, it has expanded. But from B to A, it has compressed. The volume has reduced. So let me just draw it separately, okay? So I'm just erasing them. And yeah, all okay with the questions, right? So if you had any confusion, let me know. Okay. So if I just draw them separately, this is from A to B, and this is from B to C. Sorry, A to B from the downward way. Cyclic. Right. So it should be a cyclic one, okay? In exam, they might give the other direction as well to confuse you. So you should understand the net work done, because there's work done, and I forgot to say the net work done as well. Net work done means, which means the area inside the graph. Okay? If you look at here, this should be the work done part. I'll say you why it is. So you can see the work done by him is area under the graph, this entire section. Okay, this entire section. And the work done in here is this under the graph. Now you can see the upper one is larger than the area under him. It is something like that thing which I compared in isothermal and adiabatic. Okay. The area covered by this guy when he is compressed in is smaller than the one at here, because there is a larger area covered by this expanding process. Clear? So there are two things. In here there is a positive work done because it's expanding, and here there is a negative work done because this is compressing. So the resulting work done has to be the difference of them. So it has to be this section. If I start to subtract this and this will be the net work done. Net work done. So you should understand, in here there is a positive one which is larger than the negative one. So my resulting work done, if I subtract from a positive value, that means 5 minus 2. This one is larger than him. So you will be getting a positive answer for the resulting work done. Resulting work done, you will be getting a positive answer. And I already said you that delta Q is equal to my work done. So whatever work done in here, it is positive. So the same sign is present to delta Q. So understand that thing, okay? So sometimes they might give it in an MCQ. Like let's say the following cyclic process, is there a heat input or a heat output? Not that simple, okay? They are just giving something. Let's say they have given answers. They are giving you answers like this. Consider the following cyclic process. What would be the following? What would be the heat exchange in the system? They are asking a question like that. So let's say they are giving an answer 0, and then they are giving an answer like 400, then minus 300, fourth one is minus 200, fifth one is none of the above. They are giving answer, okay, not enough information for the fifth one. So they are just giving you answers, 5 answers. So how are you going to actually find it? because just see whether it's a cyclic or a just see whether it's a clockwise or an anti-clockwise process. So in here you can see it's a clockwise process, like your clock. So in here there is a positive work done. Clockwise means positive. Just think like that. Now, like taking moment, okay? Clockwise moment is positive, anti-clockwise moment is negative. Just get that thinking. So clockwise means there is a positive work done. So the same sign is present to the delta Q. The same magnitude also. Okay? So you should understand, you should get a positive answer. So you can have this, and of course it won't be 0. So this answer is 400. So these they might trick you with these stuff. Okay? So just prepare for these. And now let's look at the anti-clockwise cycle. If you look at the anti-clockwise cycle, it is the other way around. Same thing, other way around. So delta U is anyway 0 because there is no any heat exchange. So my delta Q is equal to my work done. Fine. Let's find the sign of it. If I take the sign of it, you will be having the first one as this way. That is the work output. Okay, the area covered by him is this part. I am just doing the dotted line to compare. Okay. Then I am having the other one, which is the compression part, and I am just doing the dotted line again. This is the work done by him. You can see the compression has a larger work done than the expansion. So this guy has a larger work done than the expansion. This is a positive answer. This is a negative answer. So if you take the difference, you should get a negative answer. Okay? So the work done is negative here. So you should get the same sign for the delta Q. Delta Q has to be negative answer. So again, the same MCQ. The answer with the negative answer has to be wrong. Okay. So these are the basic things in your thermodynamics, but it is not complete because without trying question you can't understand physics. Okay. Because I can give you the theories and I just pointed out some important stuff, but if you try a question and you will be getting a meaning for it. So now let's try to deal our paper, and I think you are having exams on next week, I think. So I just introduced the tutorial 2. There are some shortcuts to remember and you might have watched that as well. And let's finish the paper 1 which I have given, then the paper 2. Okay. And I have just added only a small amount of question, like 12 questions, because we have to cover the theory and then move to questions. Because it's pointless of just me working on the board. So just try it from your side, and even if you are not attending the class, just watch the recording. Okay, try the question and watch the recording. Okay, and I'll just increase the question in a while. Okay, now for now let's deal with maximum 20 questions, because after covering conduction, Newton's law of cooling, I can increase the amount of questions. Okay, until that let's deal some small points, so which I have given in question number 2. In paper number 1, try question number 2. I think we have tried the simple harmonic and those ones. Let's try question number 6 from mechanics. So let's start that. Question number 6 from mechanics. Okay, so I'm just giving you a small break. So after the break, let's continue this. What you can do is, you can try question number 6, the 7th one. A projectile at the same range. Now see, when I'm covering the mechanics revision, I'll discuss in detail. Now, there's a thing called the maximum range. They will not give you the angle for that. Maximum means angle is 45. You should know that. Similarly, in question number 7, they are saying us it is having the same range. Not not different ranges, the same range. Two projectiles are made, they are having the same range. So just try to solve that question for now. I'll just anyways discuss it today itself. And let's finish the paper number 1, okay? Paper number 1, just let's skip question number 12 and let's move to the tutorial 2, okay? I think I was planning to discuss sonic boom as well. So let's try it then. So just take a small break and around 20 minutes and let's continue it. And you can also work on the tutorial number 1, okay? So I'm just giving you a small time for that also. So let's continue in another half an hour, okay? So let's start from where we left off. And as I plan to discuss question number, okay, let's start with the paper number 1, sorry. So I think we have to discuss the question number 2. That's basically from the case laws. I think we didn't try anything. So let's try question number 2 then. Question number 1 I have already explained. So question number 2 they are saying us, there's a certain tube. This is actually from a past paper, okay? So I just made it shorter. The past paper was anyways in the 90s, 1989 and something around that period. So there was actually so many stuff to be discussed in here. But let's start from basics so that you can try it. In that there was temperature change as well, okay? But in here there is no temperature change. And I'll just share that question as well. So here we are having 15 centimeter. Even you can use this for your chemistry papers as well. 15 centimeter. The mercury column length is 20 centimeter. And there's gas trapped inside this. There's gas inside this. So they're saying us, consider a tube with mercury thread of length 20 centimeter is placed at middle. So the either side is being 15 centimeter length. When placed horizontally, okay? Now if they are saying us, now if the tube is vertical, what will be its respect to its length? So if they are making it vertical, what will be its respective length? That's the question. So there will be, we are having the mercury column around here. And you only have to decide whether it will be the same length or not. What you can think here? Okay, so what will actually change if I start to make it vertical? Any ideas? If I make it vertical, what will actually be an additional effect? If you look at here, this mercury column hasn't any weight contributed to either side when it is placed horizontal. But when you are placing it vertical, now the weight will also influence in this system. So that's the first change you have to detect. So apart from the weight, you can say it as the pressure caused by heat. And now throughout this portion, I am going to use the centimeter mercury here. I'll say the reason why. Because they have given a mercury thread. So when you are dealing with these mercury threads and those stuff, learn to use your pressure in centimeter mercury instead of Pascal. So it will be easier. Okay, so let's try this. Now if this is perfectly balanced, the pressure in either side is the same. The pressure in both the sides is the same. But let's say, if I make this vertical, now the pressure is going to change anyways. Now the pressure of him, let's say P1, the pressure of 2 he has P2. Let's mark them as A and B, okay? So there will be confusion. The pressure is different. Now you should understand, okay, the pressure is changing. The volume is changing. But you should understand, it's in the same surrounding. So the temperature is a constant. The temperature is not changing. So if I just ask you, what law are you going to use? So now I haven't said that it is a fixed sample of an ideal gas, those stuff. You should understand the gas trapped in here didn't leave the system. even this mercury column was moving here and there, the gas didn't escape. So the mass of the gas is anyways a constant. So just get that idea first of all. Okay. So now you can apply all your gas laws which you have learned, like the Boyle's law, Charles' law, so many of them. So the main condition is the mass has to be a constant. Now if you look at here, okay, same surrounding, the temperature is a constant. The temperature is a constant. Okay, now why I am actually dealing with this pressure? You can ask that, okay. If you look at here, they are asking me to find these respective lengths. So if I just think, okay, how can I find the length? Totally no meaning at all, right? Because how can I find the length? Blindly. So there has to be something additional. So when there's a mercury cube, we know that it's something related to gas laws. That's why I came into conclusion here. And I'll say some other reason as well, a bit later, okay? And if you look at here, okay, the mass is a constant, temperature is a constant, so you can apply what law? Yeah, the Boyle's law here. Because why? The pressure inside the system is changing, volume of this is changing. Okay, let's say we are finding the volume. How can you actually find? I have to find the length, right? But from where we get the volume? So you should understand, if they give you one problem, make sure that you are going to create so many problems. Now just let's say the area of him is A and it is uniform. The area of this tube is A. So if it is cylindrical, area into the length or as the I will get you the volume. Your first idea. And don't worry to introduce something new, okay? You anyways going to find the edge. Don't be afraid of using different parameters because we can't have it in your final answer. But whenever you are dealing with these gas laws, this area will cancel off. The first point you should understand. So they will not give you the volume, but you must make sure to get the volume. How? From area into the length. The first point. So now let's write our equation. The pressure in the system is P. Area in here is anyways A, okay? A. Height, length is 15. So you get the volume. And if it is an MCQ, I will be not converting this to meters. And it's not actually essential as well, okay? Because I am calculating the pressure in centimeter mercury. So it will be easy then. That is equal to, anyway this is the same thing, so I am not going to write it. Now if you look at here, this is the PV product in system 1. I am applying Boyle's law, P1 in here. The pressure is P, volume is A into 15. But now let's say the length of this is X. So the volume in here is A into X. Pressure is P1. So the PV product is P1 A times of X. Okay. Now I say the mass and the temperature is a constant. So we can equate both of them. So P into 15 is equal to P1 into X. Your first equation. Now how we are going to determine the second equation? If I want to find the second equation, how are you going to find it? Again, the gas isn't leave the system, temperature is a constant. You can apply the Boyle's law for B part, section B. So I am applying Boyle's law for B. I am applying Boyle's law for B. So I will be having pressure area into 15 is equal to P2 into area into X. P2 area into X. So we are getting two equations. See here, This part is not x, okay. Now see, don't take it as y as well. Take it in terms of this x. So if you look at the total length is 15, 15, 30 plus 20 is 50. The total length is 50. The length of him is 20. So this has to be 30 minus x. When you add them, you will be getting 50. See, 30 plus 20 is 50. X minus x is 0. So 50. So we have to see 30 minus x. So I can equal these two answers now, right? So I will be having P1 into x is equal to P1 into x is equal to P2 into 30 minus x. Area will cancel out. So I am just adding up things, okay, since we have to discuss more question. So we are getting our equation number 1. Now how you are going to find the next one? This is P1, P2. Anyways, you don't know the pressure, right? How can I find the answer for x? So now you are having confusion among you. If you look at here, okay, we are able to write from our gas laws till this point. But how can I get a relationship between P1 and P2? That's why you have to observe it keenly. P1 and P2 is present in this system. Okay. So observe at this system now. If you look at this system, it's something like your H2O. You are having an atmospheric pressure, gas liquid, the depth of the liquid. You have to find the pressure at this point. So the pressure at this point is P2. Anyway, everywhere is P2. So this part is also P2. The pressure exerted from the top is P1. So you can say P1 is equal to P2. No, you can't get that because you are having a mercury column. There is a weight contribution by it, and the weight is inside an area. So there will be a pressure created by him. So you have to find that it is P1 plus. Now that's the reason why I say to calculate in centimeter mercury. You can find it using centimeter mercury because length of the mercury column is 20. The pressure created by him is 20 centimeter mercury. Clear? The length of the mercury is 20 centimeter. So if you calculate in centimeter mercury, it is 20 centimeter mercury. That's it. And now that is equal to P2. So I think the amount of information is actually lower here. Since I just typed this question, let's take the initial system as atmospheric pressure. Then we can try it. Or if I just get your value for him, you can try it. Okay. Take a value for P1 as 80 centimeter mercury. Now in that past paper question, they have given it in detail. Okay. Now I have to give either two information. If I am not giving you this, I have to say that the atmospheric pressure is 1 into 10 to the power 5 Pascal, or let's say 20 centimeter mercury. From P, I can find P1. Then I can come step by step. Okay. So this is the basic idea. I just want to try you the past paper question. Okay. To get the past paper question, what I did, okay, I applied Boyle's law separately for these two systems. I operated Boyle's law for these two systems. That's the first understanding. Then the centimeter mercury, sorry, the mercury column, how it produces the pressure. We took it in centimeter mercury. So I mainly want you to try that past paper. I'll share that as well. So to get that, you should know these stuff. And if I give you a value for P1, you can find P2, then substitute only here. Or else, I should give you the atmospheric pressure this. So let me just modify the question, okay? I just randomly typed it and let me just get you a value if you want. Atmospheric pressure, let's say it is meaning meaningful answer, let's say 20. Let's take something a value like 20 centimeter market itself. So you have to multiply them. P1 is equal to 300, I think. 300 over x. Substituting in here, you can find P2. Then you can substitute only here. Okay. So just want you to get that idea. So let's move to question number 5 is a cyclic process, right? I said you mechanics one as well. So let's try question number 5 there, not 5. Let's try question number 6, okay? The dou part, mechanics, and let's come again for the thermodynamics. Question number 3 is thermodynamics. So let's try question number 6. So you want to just take a screenshot of it. So just let me know the answer for that, okay? Okay, so let's try question number 6 then. They have given us a dou here. They are asking the forces in the hinges. So you should understand it's a basic logic, okay? Now if there is mech students, you can really understand it from jointed rods, upward and horizontal one. Let's determine how it is done. Now this dou has a weight acting in the downward direction. So there has to be someone holding that dou. If this system doesn't hold that force, now if there is no any upward forces, let's say if there is no any hinges, the dou is going to fall down. So there has to be someone who is going to make sure that dou is stood vertically. Someone catching at the two ends. So that person should provide a force equal to the weight in the upward direction. In the upward direction. So it is contributed by this guy. The vertical upward forces has to be upward. None of them has to be downward for now. Because they has to be upward. Because the addition of them will contribute to the weight. Clear? There is a dou. Because of the weight will fall down. So there has to be someone providing an upward force. That upward force is provided by the vertical components of the hinges. Okay. So if you eliminate answers, you can't have answer number 2 because the force is in the downward direction. You can't have answer 3. You can't have answer 4. So it is either answer 1 or 5. It's either answer 1 or 5. Okay, so we soon get you an idea, start eliminating answers. Now if you observe here, now this dou, if you now ordinary at home, this dou doesn't move here and there. It is fixed and it is capable of rotating. It doesn't move horizontally. So there has to be a horizontal force, let's say in this direction. This horizontal force has to be cancelled by him. Clear? It is mainly because it mainly determined by the way you open the door. Let's say if you open the door this way, if you start open the door, these hinges start getting pushed in. So to avoid that, there will be a force in the other direction. To maintain equilibrium, there will be an opposite force. So understand again. Let's say I am opening the door this way. So when I am opening the door, this nut is getting out. So to avoid that, there has to be a horizontal force in this direction. Okay with it? I am opening the door. this part shouldn't come here. So I'm opening means, this is my door means if I'm opening, you can see my hand is going away. So it shouldn't happen. There has to be someone dragging it backward. So the horizontal component is providing it in this direction. But you should understand that this part, the bottom part, should cancel that horizontal force. When you just experience your door, the upper part is coming out, bottom part is going in. This part is pushing in. I'm opening it seems. This point is coming out, this point is like pushed in. So the horizontal force in here has to be opposite to it. Okay? So every time in our door system, you should have a vertical upward forces. The horizontal component should be in opposite direction. Now they haven't said you that the door is opening or closing. They are just asking you what are the direction of forces given to the door by each pivot hinges. So you should understand horizontal component should be opposite direction. So if you look at my answer either 1 or 5. Answer number 5, they are in the same direction. It is wrong. It is answer number 1. Okay. Now you can see the reason why I am saying is if I am opening it, this part is coming out, whereas this part is getting pushed in. That's why we are having two opposite direction. Okay. So if you are again having any doubt, just DM me. Okay. That is, you can message me because you might get confusion with these horizontal forces. They has to be opposite. Okay. And let's move to the projectile one. I mainly wanted to say this because you are having exams as well. Just remember they get confused with this. They can see how if you are dealing a projectile motion question, you should know the angle and the velocity. But they might not give you the angle. They will be saying it's a maximum range. The maximum means every time the angle has to be 45. Only when the angle is 45, you are having a maximum range. Okay? Only when the angle is 45, you are having a maximum range. Okay? So just remember that point. When it comes to our mechanics division, I'll explain in detail. Maximum range, the angle is 45. But not in this question, okay? But in this question, the story is different. The projectile has the same range. It's not the maximum, same range. Now, there's a condition behind it. I'll just say you the reason why. Now, when it comes to mechanics division, I'll say it in detail. For now, just remember, let's say with the velocity, I projected an object. The angle is theta. So, this is going to reach a certain range. Now let's say if I project this object with an angle of 90 minus theta with the same velocity, I'll be having different heights but I'll be having the same range. Okay. So the condition for same range is same velocities has to be present. If it is projected with theta, this has to be projected with 90 minus theta. Okay. So just remember these two conditions. It will be helpful for your exam. Because they might not say you the angle, they will be just giving you this information. And there's another one point as well for projectile where you don't need the angle. If you have an explosion, let's say if you have an explosion, there's a mass, it exploded, this original path is going to continue the same range. If it didn't explode, it's going to continue the same path. So let's say the mass is 2m, it breaks into identical pieces. Now this mass, let's say it moved a distance x. So if they ask me to find the distance of him, you can use this center of gravity equations. 2m. Okay. You can use the moment equation to find it. Taking moment about him. M into x is equal to m into x. Okay. So you might not understand this. In the mechanics division, I'll say it in detail. Just for exam, just remember this. Okay. Somewhere in the middle, the projectile exploded. Its original path is going to continue by its original mass. So the others are here. So you can take moment about some point to find the other distance. Let's say the mass is 2m, right? Let's say 3m, 2m. 2m into x. This has to be m into x by 2. Like taking moment, okay? Moment about O. 2m into x is equal to m into, we don't know the distance. So you have to find y. So I'll discuss them in the mechanics division. For now, remember this for your projectile, okay? These are the questions where you don't need the angle, and for this you don't need the velocity even. Okay? So let's move to question number 7. A projectile with the same range, when the when the maximum height attained by it is h1 or h2, which means one has the maximum height of h1, another one has the maximum height of h2. If you still didn't get this angle idea, it is like you are projecting with an angle 30. So 90 minus 30 is 60. So when you project the projectile with an angle 60 and 30, you would have the same range. Okay, so just note them down. So one projectile has a maximum height of h1, the other has a maximum height of h2. So now they are giving you the first idea to find the. They are giving you the idea for the height, the range r and h1 and okay. They are asking a relationship between r and h. So let's try to find it. Now for now I'm just going fast, okay. The equation for my range is 2u squared sin theta dot cos theta over 2 g. Okay, let me just derive it. If I use s is equal to ut, and the time is going to s is equal to ut plus half at squared. So the projectile is made with an angle u sin theta for h2. Okay, let's take h1 and h2. The maximum height is h1. You have to know the time, so you can use these. Okay. Without this, we can try. Okay. To find the time, we can use v equal to u plus at in the upward direction. Final velocity is 0. Initial velocity is u sin theta minus g t. So the total time taken for the projectile will be 2u sin theta over g. Yeah, I just did it correctly. So the equation for my range will be 2u squared sin theta dot cos theta divided by g. This is my equation. Now this is a general equation, okay? So just remember them. In exam hall for MCQ, don't waste time, okay? So just remember this equation. R is equal to 2u squared sin theta dot cos theta over g. And similarly, if I find for the height is equal to u squared over 2g. Okay? So this is also a general equation. The maximum height. So just remember these two equations in projectile. Next time no need to derive them. Range is 2u squared sin theta dot cos theta over g. H is u squared g times 2. U squared over 2g. So what I can actually do here is wait a minute. So they have to so now we have to find a relationship between, okay. When another mistake, the angle has to be present. U sin theta whole thing squared. U sin theta whole thing squared over 2g. Okay, so this has to be my equation. Now if you look at here, we want to connect R with H. Okay, so what is common in both of them is, you can see sin theta is present for H, but the cos theta part is absent. Wait for a while. So if I write an equation for H1 is equal to, okay, I'm just doing a separate diagram. H1 is u sin theta, the height is H1. So u sin theta is my vertical component. The reached maximum height is H1. So H1 is equal to u sin theta whole thing squared over 2g. Okay, this is my answer. If I want to write for H2, I say it's a condition. If they should have the same range, they should be projected with the same velocity, but with an angle of 90 minus theta. So now the height is H2. Now be careful, okay? Because the vertical component is u cos theta. U sin 90 minus theta is u sin 90 minus theta is u cos theta. So if I substitute in this equation, H2 is equal to u cos theta whole thing squared over 2g. Okay, with this, the vertical component in here is u away from the angle sin, u sin theta. Here it is u cos theta. So just remember these two equations. Not that important, okay? For now you should know these two equations. Now see, my answers consist of H1 and H2. The product of H1 and H2. So you know that you have to multiply them. But before that, let's find a story. In here there is 2u squared sin theta dot cos theta. Now in here the common thing is u squared. But I don't have sin theta and cos theta. That means together. Here I am having sin theta, but I don't have cos theta. Here I have cos theta, but I don't have sin theta. So what I am going to do is, I am going to multiply H1 and H2. I am going to multiply H1 and H2. So I will be having u squared into u squared is u to the power 4. Sin squared theta and cos squared theta is sin theta dot cos theta whole thing squared divided by 2 into 2 is 4, g into g is g squared. So it is 4g squared. So if you observe nicely here, u squared u to the power 4. Sin theta dot cos theta is sin theta dot cos theta whole thing squared. G has become g squared. So how am I able to do this? So if I take the square of r squared, 2 squared is 4, u squared is u to the power 4, sin theta dot cos theta whole thing squared, and I am having g squared at the bottom. So you should understand, instead of this part, u to the power 4, sin theta dot cos theta whole thing squared, g squared, I can substitute 4 times of h1 h2. So r squared is equal to 4. Instead of this part, now see, this part is only present. So this 4 has to be sent to the other side. It is 4 times of h1 h2. So for my final answer is r is equal to 4 square root of h1 h2. So just remember it. So irrespective of the question, whether you might get the same or not, to get the idea, same range means it has to be projected with same velocity. Angle theta means other has to be 90 minus theta. Okay? And question number 9 is there. Question number 9 is 0. You can watch that. But I think there was another one important. Okay? Question number 3. Yeah, we can try question number 3 then. Question number 3 is left and question number 8 is left. Let's try question number 8 and move to 3. Okay? Waves. So just take a screenshot of it. Okay, just remember the key points. Okay, maximum range, same range, and that one is explosion. So I'll get you questions one by one, and I'll explain in detail in the mechanics revision. Okay. So for the 8th one, I need a small space only. They are saying us, a wave of frequency 120 Hz produces a phase difference of 6 pi between 2 points on its path at 9 meter separation. So if you look at here, the frequency of the wave is 120 and phase difference. Now I said in the last class, I won't be discussing everything in detail. I'll just explain them as question. So this is the point. If I had wave, let's say a progressive wave, this part is one phase, this is in the other phase. So if I consider the phase difference between these 2 points, it is 5. This 5. But with other points it will be different. Okay? That's the idea behind phase difference. So they are saying us, the phase difference is 6 pi. Now there is an equation to find the phase difference, which I didn't say in the last class. So phase difference is equal to 2 pi over lambda. Just remember it. 2 pi over. There is also another thing, phase shift, where you will be getting the periodic time. I said similarly, 2 pi over lambda so that's 2 pi over lambda into the separation delta x. This is the thing. This is known as phase difference. There is another thing as well, phase shift, where we calculate the time. So it is something like you are drawing displacement with distance here, and there is another thing called phase shift, that is 2 pi over periodic time. See the similarity. I will decide it in a change in time. So 2 pi over lambda into phase, that means difference in length is your phase difference. Phase shift is 2 pi instead of lambda periodic time into my time difference. Okay. So just remember these two key equations. That's the way I will be just teaching. That means these are small stuff. With questions I will explain them. Okay. So we can look at the phase difference 2 pi. We don't know the wavelength. Separation is 9. Okay. The speed of the wave is questioned here. So the phase difference is 6 pi. So from here I can find the wavelength. That will be around 18. Lambda is equal to 3 meters. Okay. Now we can find the speed here. V equal f lambda. Frequency is 120. Lambda is 3. My answer is 360 meters per second. Okay. Answer number 3. And again, let me know if you had any confusion or if you have any problem in my teaching method also, let me know. Okay. I feel like I'm just going in a speed, but I just want to try more questions. Then the theory part, questions are one which is going to explain in more detail. Okay. So let me know if you had any issues, and the time slot also just let me know. Okay, because there are few audience and even today there's so much audience as well. So let me know with the time issue as well. If you're watching recording, it's fine, but a live interaction would be much more better. So just let me know with your time slots. And anyways, in Saturday, Sundays we have candy classes, so you might be busy in that. And so let me know. Okay. So this is the phase difference. Question number 8 is done. Then we have question number 9 and question number 3. So those are the 2 questions left. So I'm just erasing the projectile one for now. Now even in the next tutorial I have given some good questions. You might, that means in my YouTube channel which I have given, if you went far bottom you will be finding some stuff which I have done with papers. So in that I have just teach some shortcuts as well. You can just watch that. Or else fine, I'll just discuss it with time. Okay. So let's look at the next one. Question number 9. So we are giving a cyclic process. We have been given a cyclic process. You can see it is not actually a circle. Pressures are P0, 2P0, 3P0. P0, 2P0, 3P0, and volume is V0 and 2V0. If you observe here, to try this question, just break it into pieces. That's the way how I did in the cyclic process as well. To find the work done, I took the up part, bottom part separately. So you can get an idea like that. So if you look at here, if I divide the section from this part, I start chopping this out, I am having a process like this. I am having a process like this. If I take the bottom part, I am having a process like this. Like this. So if you look at here, in it is symmetry, you might say it is 0, it's fine. But let's find with calculations. If you took this section, the net work done is the area of him. The net work done. it is half into the area is 3p naught minus 2p naught p naught. Volume difference is p naught. That is the area or the net work done by him. Net work done. Okay. The area inside this region, surrounded by region. And the net work done by this guy is half P naught into V naught. Again the same. If you nicely look at here, just take one point, okay? Let's say I am taking this point, starting from here, reaching the same place. Starting from here, reaching the same place. That's the way how I started this question. And if you look at here, gas is expanding. There's an area covered by this region, area covered in here as well. Sorry. The gas is expanding in this section, okay? So the area is this one. But if you look at the top line, area is going to be this entire section. That's why this difference gives you only this part. Here. So get that idea. This straight line has a larger area. If I had a different marker, I can just point it out. And this is the area by the smaller one. By expansion, by compression. So compression has a larger area than expansion. We'll just write that down in here. In this one, compression is larger than the expansion. So it is a negative work done. So this answer has to be minus. What about here? Now if you look at here, gas is expanding. The area is this section. And there is this compression. So this is that section. You can see expansion has a higher area than the compression. So the work done in here is positive. Okay. So overall work done will be 0. You can go for the answer number 5. It is 0. But I can give you different shapes as well. I can make this triangular structure with B and give you. Do it in the same way. Break it into pieces. Just clip this from here. You can find it. So in cyclic process, we think about the net work done. Okay. So if you had any confusion, just let me know. So 9 is fine, and let's go for question number 5 then. Question number 3. There are laws like partial, Dalton's law of partial law, that is explained in this, okay. It's not explained in here, but I'll just get your question. So I'm just erasing the. So question number 3. And also just make sure that when you are trying the phase rules now, because you almost covered the heat part, but from my side, from theory side also, heat is almost covered. So the thing is, you can work on the past papers now. Even when you are dealing phase rules, make sure that you are going to mix the amount of question. Now don't just keep on do past paper with what. You just don't do the phase rule with only thermodynamics, because you will be limited. If you try thermodynamics, then try another question. Let's say 10 question from thermodynamics. Try another 10 from a different part. Let's say electrostatic. So that you can exchange the amount of ideas. And you can also find some relationships. You can find some ideas, okay. And also in an exam hall, you won't get first 10 as thermodynamics, next 10 as a different set. You have to interchange your ideas quickly. So working on phase rules now is somewhat crucial. Make sure that you are going to exchange the amount of questions. 10 from thermodynamics, 10 from heat, something like that. And work on the past papers, okay. From my side, I will just get you outside questions, some past papers. I think in tutorial 2, I have added past papers more, which is actually before 2000. So I won't interrupt your pattern. So So just try past papers from your side, okay? It's better if you start from 2007 and onwards. 4 is fine, but 7, okay. So let's move with question number 3 then. 5 moles of O2 were present in a closed container at 300 Kelvin. There is an oxygen tank, 5 moles, temperature is 300, pressure is 5 into 10 to the power 4. So they are saying us the molar mass of oxygen is 32. Another vessel with the same volume. They are having another vessel with the same volume. With 2 moles of helium, at 150 Kelvin. Find the pressure. Okay, so let's write our relationship. You can deal with ideal gas laws. You can use PV equal nRT. The pressure is 5 into 10 to the power 4. Volume is V. Number of moles is 5. R into temperature is 300. Okay. And if I write the equation for him, pressure is unknown. Volume is same as again. Number of moles is 2. Universal gas constant into 150. Okay. So you can divide both the equation. So P over 5 into 10 to the power 4 is equal to 2 over 5 into 150 over 300. Let's see whether my calculation is correct. R will anyways cancel, that's why I didn't write them. 150 over 300, 2 over 5, yeah. So we'll be having 1, 2. So my answer for the pressure will be 1 into 10 to the power 4 Pascal. It's a simple question, but I want you to say another way of doing this question. Now let's say, if I had the pressure as P, I want to find the pressure anyways. You know the volume is the same for both of them. Volume is the same and universal gas constant is the same. This will be not helpful in here, but some questions it will be helpful. Better than writing equation, this method I feel it is easy if you practice well, okay. Now see, my equation is PV equal nRT. Volume is a constant for both of them, same, okay. R is anyways a constant. So what I can write is P over N, T is equal to a constant. Okay, so then you can substitute. In here you will feel like it is the same. I will get you a hydrostatic question, okay, from past paper. Without writing equation, learn to write these proportionalities. Pressure is directly proportional to N into T because these two are constant. So understand, if the number of mole is increasing, pressure has to increase. But in here the number of mole is reducing. From 5 it is becoming 2. So the number of mole is reducing. And wait a minute. Temperature is reducing from 300 to 150. So temperature is also reducing. So your first answer should be, pressure lower than 5. That means it has to be anyways lower than the initial pressure. So you can't have answer 1, 2, 3. You can't have 1, 2, 3. It has to be either 4 or 5. Now sometimes luckily you might have the answer. That's why I'm saying you this. And in case if you remain with answer 4 and 5, now you can continue with the calculation. Just learn this stuff as well, okay? So I'll just say you some short ways which I used to practice. And as I said, there's a shortcut in tutorial 2. If I say it now, it will be like lengthy. Yeah. Let's see if my answer is correct or not. So now understand, number of temperature is reducing by 2 times. 300 has become 150. So it is like the pressure is reducing by 2 times, right? Get an idea. So if it is 5, it has to be 2.5. Okay? 2.5. So if you are confused, just write the equation again. But I'm just doing it that way. 5 has become 2.5 into 10 to the power 4. Temperature is reduced 2 times. So pressure is also divided by 2. And the number of mole is reducing by 2/5. 5 has become 2 mole. So 2.5 has to be 2/5 of the initial. The answer is okay. Okay, so just follow that away. Let's see in a while. If I substitute in the equation, you will get the same answer again. Pressure 5 into 10 to the power 4 divided by number of mole is 5, temperature is 300, and the pressure is unknown, moles is 2, 150, so 1. Yeah, you are getting the answer, okay? So just see it my shortcut as well, and I'll give you a hydrostatic question where you have to deal with that proportionality marks. Yeah, so that's it for the paper number 1. Tutorial 1 is completely done. Simple harmonic, I have just included only 2 questions in here. I'll discuss only 1 question from tutorial 2. Now tutorial 2, second question. Read it carefully, okay? Because I have given us a ball is released from a height edge. So just carefully read that. The ball is released from a height. So usually it will be calculated in the distance travel this way, right? The displacement. But read the question, okay? I am saying you the height from the ground, the last statement. Which means I am measuring the height from here, okay? Measuring the height from here. So be careful with that also. And I have given to draw the velocity and height. Right from your side, okay? Velocity and height has to be drawn. It's quite a new thing for you. Nothing to worry. Whatever equation you know, just write it. The equation you know is S is equal to ut plus half at square. So when you write it, the final velocity, sorry. We should include the v. So I can write v down. V squared equal u squared plus 2gh. So we'll be finding that v is my y-axis. So make this as the subject. V is equal to square root of u squared plus 2gh. And if the initial velocity is 0, you won't have this u squared. So you can see y. 2g is a constant in square root of h. H is my x-axis. So it has to be square root of my x. Again, h is my x-axis. This is square root of h, right? So it is square root of x. So you have to have a graph like this. You might think it is that, okay? But we are measuring the height this way. So that's why we are having curve this direction. Okay, so be careful with that. So you can try that as well. I want to mainly say you only one question. Okay, wait. Yeah, question number 7. The last class I said you that we should be having, if I get you a graph, you are in trouble. Now, simple harmonic is a sinusoidal path. So understand. Now you can do this question with many 2 things. Wait a minute. Okay, so you can do this in many 2 one method. Okay. If you have this is my graph, my amplitude is this, okay. So in this question the amplitude is 40 and the periodic time is 20. Periodic time is 20 and I'm asking you the time taken to displace 20 centimeter. So it can be in the upward way or the downward way. So I'm asking you to what is the time taken for 20, just find the first time. So you know that simple harmonic displacement is equal to a sin omega t. Okay. You have been given the displacement, it is 20 centimeter. When it displays 20 centimeter, so x is equal to 20. You don't know the amplitude. Sorry, you know the amplitude. You don't know omega. To find omega, I said your thing in the last class. So try it from your side, okay? So let's wind up the session then. Yeah, watch the recordings and let me know with your time slots, okay? Because there's almost no one now, okay? What has left? So just let me know with the time. And yeah, if you want any improvement from my side also, just let me know, because sometimes I'm just skipping some steps. Some might be unable to get that at once. So let me know everything, okay? So let's finish this here.